Good afternoon, everyone. Thank you very much for coming in today. I know that you're quite busy. Thanks for muting your mic, and of course, there will be a question period at the end. And I'm actually very glad that Lars accepted the invitation to come to give a presentation on the growing importance of the replicability of empirical work. I say this because I know he's a very busy person with multiple jobs, in fact, across multiple countries. He is presently on the faculty of the Department of Economics at Cornell University, Executive Director of the Industrial and Labor Relations Labor Dynamics Institute, affiliated also with the US Census Bureau. He is the editor, the data editor of the American Economic Association, the managing editor of the Journal of Privacy and Confidentiality, and on several advisory boards of restricted access data centers in France, of course in Canada. We're glad to have him at the CRDCN, and in the US. And in addition to all this, he's also a labor economist who does research, empirical researcher with expertise in manipulation of detailed longitudinal linked employer and employee data, and was involved in the design of this kind of very detailed data and handling all the privacy issues, knowing that this type of link involves firm data and so on, and so all these complexities. So he's the best person to talk today to us about the issues involved in the reproducibility of work. Before I give him the floor, I wanted to give you a quick update. I know I started saying that the replicability of work for RDC researchers is a policy that will eventually be implemented, and there's been a committee that has started to draft the document last year. It hasn't been approved yet, but I think it's on its way eventually. Of course, the pandemic has changed a lot of things, and it's right now on the back burner. The network has obvious new priorities right now since the pandemic, but I thought it's always good to start having a sense ahead of time and prepare. I think that there is also some extra information I can send on having a template to help researchers build their folders in preparation for replicability. But I will let Lars tell us all about what we have to expect ahead of us on this. So thank you, Lars, and you are welcome to start.
Okay. Thanks, Steph. Yeah, pleasure to come to this session. I'm only sad that I didn't get to actually come. We'll have to pick that up at some point in time. Stephanie mentioned a few of the hats I wear. I call them hats, not jobs. Jobs you typically get paid for. Many of those I actually don't get paid for. But as is usual in academia, I may wear many hats, but nobody's responsible for what I say except me. Although some of the things you might hear might turn out to be American Economic Association policy somewhere in the future. Who knows? I want to just linger a moment on my title slide because I'll get back to that. It seems like a traditional talk title slide, but you will see at the very bottom a small logo that has CC BY and C in there. It's a license that allows people to reuse this. And I'll get back to licensing because it's one of the things I constantly re-explain to authors about what it means to access data and what it means to redistribute data. And that is, of course, particularly pertinent in RDCs, where you might have gone through a lot and a long procedure to access data, and you definitely don't have the authority to redistribute it. But that is actually a more general problem. Okay. So I'm going to breeze through many of these things where I'm happy to expand on some of those later on in the question period, but I just wanted to make it clear where I'm situating most of the discussion that we're talking about. this is sort of a continuum of replication that goes back most recently to the National Academy's report in the United States, Reproducibility and Replicability in Science, where the continuum, and it has various labels that get attached to parts of this continuum, extends in their and now my terminology from reproducibility, which is very much in the narrow sense, via replicability, which is broadening that aspect a bit, into generalizability. The way to think of this is that reproducibility is very much very narrow reproducibility. You've got the same data, same code, same methods, same context. You're literally looking at, is this credible what these guys did? Did they not make any errors? And that might seem trivial, but as it turns out, it is not quite as trivial. I'm going to talk less about replicability, except for the fact that reproducibility, at least in my vision of things, is the first step to larger replicability and potentially generalizability, where you might say, well, these guys use data, I'm going to use R, or they used the 2018 wave and I'm going to use the 2020 wave to assess these kinds of things. Those are generalizable aspects. And does the particular labor market phenomenon that you studied with this data actually apply outside of Canada is generalizability. But in order to get there, the first study that does these kinds of things needs to be credible, and that's where computational reproducibility gets in there. Now, traditionally, this has been, and it has been for the past 30 years, a matter of concern in the sense that many people have found that lots and lots of economics and other articles are not actually computational or more generally reproducible. But there has been progress since then as well. When these discussions first started in the 1990s, we didn't have a lot of what we today consider to be an integral part of the academic infrastructure. And I throw in there a bunch of things, and if you want me to dig into some of those, I have another talk where I can spend the entire hour just talking about these things. But replication archives have proliferated. Data policies, data availability policies, the AEA states from the 2005-2006 era have emerged. I call them data and code availability policies because it de facto code was always expected, but somehow subsumed. But we have many other aspects that support reproducibility and replicability in a broader sense. If you go back to the 80s and 90s, many people would have custom software, implementations in C, Fortran, COBOL, whatever you can think of. Whereas today, most of that is in common languages that are commonly available. Some of those are actually even open source, or at least in part. If you use Stata, you have a lot of open source code that you will use because you're using tons of Stata packages. All those things that you take for granted definitely were not back then. Of course, in the RDCs, you're also using SAS. SAS is not open source, so it's not the only thing that's going on, but it provides a common language and a common concept that people are familiar with to share code and to that extent improve reproducibility, at least in theory. And the expansion and the easing of access to all sorts of data, whether it's public use data on semi-closed networks like ICPSR or the Canadian Data Liberation Initiative, or more open networks like the IPAMs, or even very restrictive networks like the CRDCN and its equivalent in many other countries that have proliferated in the past 20 or so years. We just came off a month-long set of conferences to party around the 20th anniversary of the CRDCN. Many of the other networks are around that time as well. The American one is a bit older, the German and French ones are a bit younger, but those networks are a key part to why we can even start talking about reproducibility, because they are shared networks. The data that you have accessed is not yours to claim as your own. It is for a lot of people, in some cases hundreds of people, to also access. And I'll be getting back to that, of course. So those are elements of improved reproducibility. The key concern voiced generally in the economics discipline is that there's quite a lot of restricted access data, and what we have out there in terms of code and data often leads to not fully reproduced articles. I consider the glass to be half full. It's better than nothing. And in particular, I don't consider that air half to be problematic because much of that restricted access data is accessible to many other people. It's not universally accessible, but reproducibility doesn't require that everybody access it. It requires that the research be credible and that some people be able to access it, and that those people are not biased towards sort of supporting insincere science, if you like. We'll get back to what we mean with that in a moment. So why is this still a matter of concern? Why was that concern? Why was I, for instance, as some other folks, appointed as data editors of journals? Well, making the code and data available doesn't mean that it remains available, and doesn't mean that what is provided is actually functional. So you will find lots of well-intentioned researchers who put all of their materials on their personal website, and that is fabulous the year that the article appears, and after that it degrades rapidly. So failure to curate needs solutions that are infrastructure solutions, and where there's a training need to get people to think about it in more structured ways. Even after 30 years of complaining about it, economists as programmers suck. Believe me, I've seen so many bad archives, and there are some very simple things, and I'll get to some of those sort of top 5 at the end of the talk, that are just not sustainable and that really should be trained out. This is a lack of training, but it also is something that I'll get back later again as well, that even if you did program things correctly, you may not have run everything at the same time, or you may not have version controlled your code. So we very often find in our experience that we get back from the others, oh, sorry, that was the old table from the previous version. We forgot to replace it in the paper. The code produces the right one, or vice versa. So these are things that detract from they might be hassles, they might be nuisances, or they might be impediments to actually getting it to work. That kind of depends on where those bugs are stuck in the code or what kind of shortcomings we have there. The other problem is that economists in general, social scientists in general, have poor data citation practices. Just telling me broadly where you got the data from is like saying, yep, I found that straw in that haystack. It's in there. You can get it too. And that may be solvable. You may be able, from a verbose analysis of the text, to figure out what is the data that the author downloaded, and let me see if I can figure out the same thing. But we're supposed to build on prior research, on prior efforts, on prior publications, and the efficient way of doing that is to have better information about provenance. Okay, so what has been done to sort of address some of these things is essentially what I call a greater round of enforcement of data and code availability practices. Like I said, they've been around since the early mid-2000s, but as it turns out, they were weakly or not at all enforced. And so the idea of researchers self-policing themselves more or less failed, because there is no robust, and this is my opinion, no robust post-publication feedback loop that forces people to do that. And so the only other option for that right now is to move that feedback loop prior to publication, when you have the greatest control over what's going to be published. And this started out more or less simultaneously in most of the social science disciplines, in political science and statistics, and in economics. While I was appointed in late 2017, the notion that we should be hiring a data editor at the American Economic Association has been floating around for several years. It kind of lingered because they couldn't quite figure out what the data editor should actually be doing. So my initial job description was figure out what you should be doing, which is always nice to have. The result of that is that I'm responsible by now for data policy at the American Economic Association in a broad sense. Most of the day-to-day work is around enforcing data and code availability and reproducibility at the 8 journals of the American Economic Association. So we slowly migrated these into the system that we built up. They're all now in there. And so the data and code availability policy applies to all of these at present. we get to see these materials, and I'll go through what that actually means in a moment. One of the things that, after having talked to lots of people, was to reformulate our data availability policy, make it clear that it is also a code availability policy, and make some of the things clear. You certainly have heard about exemptions from the data policy that were occurred in the past because you were unable to provide the data to the journal. That's out the door. There is no exemption from the policy. The policy covers what you need to do when data cannot be shared publicly, because that's a huge chunk of what we do. And the key aspect of that is transparency. Whatever you did to access the data is what needs to be done. And if the data is hard to access, then you should provide it to us. But it is primarily the access to the data that needs to be reproducible. Now, that's trivially true if you click on a URL and you download a data set, but that isn't always the case, not preventing reproducibility, as I'll get to in a moment. One of the other key changes is that previously this was after your paper was accepted, and then at some point in time you uploaded some stuff or sent a zip file to the AA. We moved that to prior to acceptance, and that works wonders when you are actually the last checkbox that needs to be checked before a paper gets ultimately accepted and then published. People work a lot harder at compliance than if you just tell them this would be nice to have. Really astonishing. So the key aspect of what my team is doing is to verify that all the conditions are met, that somebody, possibly us, but not necessarily us, can successfully reproduce tables, figures, and numbers in a paper. Okay, so our efforts turn around three main factors. One is that we preemptively improve code archives. Improving means that when we get them, they may not be fully reproducible. When we're done with them, they're hopefully much better reproducible. We also wanted to get better archives, greater transparency into what stuff is needed to do that, ensure that enough information is presented and that the information is clearly presented and findable. And better provenance tracking, getting at the data citation problem that I outlined earlier. So RDCs obviously in this particular context pose a particular challenge because for one, how do you check code when the data access is complex? You guys have often gone through month-long, week-long processes of accessing the data. Sometimes it can take years. So what do you do when that's the case? RDCs are not unique in that, but they certainly are partially there. How do you improve archives if you don't control the data? Steph mentioned earlier about policies being developed within the RDC and with StatsCan about getting better control of that. But how can you actually have better archives if you don't have actually control over some of that? And the question we most often get is, how do you document data provenance when you can't provide the data, right? Well, that's actually the wrong question. The right question actually is, how did you get the data in the first place? And again, the generic process is that you applied for the data through a process that describes the RDC, but it might describe many other processes as well. We get lots of papers where people have purchased the data from a provider. They might have signed an NDA with a data provider, or you went through your university library and they have a subscription to some service that gives you access to data. It means there's an agreement in place that somehow needs to be provided. So you must be able to describe the data. In the Canadian sense, in the RDC, you can. It kind of seems obvious, but you'd be surprised how many people don't necessarily put all the necessary information. If you can't name it, how can the next person request it again? And you can make a very convoluted description of what it is, and sometimes that is actually needed if you're talking about, say, extracts from HR systems in private companies or things like that, where there is no such thing as a well-defined data set, but there is no other data system, and so the query is the description. But in the sense of we are using Canadian, Belgian, Danish data of some sort, you can typically give it a name. Somebody has given it a name because you somehow managed to get access to it by calling it something and asking for it. And so that's the first step of being able to do that. But even if you're in a system where you might have to go through an online query system, so one example here that came up yesterday, literally in review of a paper, are the World Bank's World Development Indicators. And just telling me that you extracted them from the World Bank World Development Indicators doesn't give me enough information to say, well, what data did you extract from there, right? There are some 264 countries. There are some 700 series. There are timeframes you need to specify. And so specifying how you got the data means that sometimes you may need to provide a verbose description of, well, first choose this country, then choose this particular time series, and you need to be precise. If you're looking at GDP per capita, as it turns out, this system has at least 2 series, and you need to specify to me and to the readers potentially of the article which one it is that you use. If there's only 2 of them, I might be able to try them out, see if one or the other works, and that ultimately is a robustness check. But sometimes that's not so obvious. And so sometimes if you can't give the data, you can give the SQL extract. I've gotten answers back from researchers who said, yes, but the SQL is confidential because it reveals passwords and other things. I'll get to that. That's not insurmountable. You can still describe what kind of extract that was so that somebody has a reasonable chance at getting similar stuff. So the key aspect here is that you need to document these kinds of things. What do you need to request? Can you specify a name? Can you specify a digital object identifier? Where do you request it? Is there a website? Don't give me your local RDC administrator, as helpful as they might have been, but the next replicator might not be talking to that same person. Give me an institutional email address, ideally a website. If you requested data through a Freedom of Information Act or some other mechanism, give me a copy of that if I need to redo it again. Or at least in the US, some Freedom of Information Act requests are actually stored on the agency's website once you have requested it. And so it's worthwhile to go back and see where's my request there. And don't assume too much prior knowledge. There is value added in having gone through a long process and having done that, and you may now have data that others might be really hard-pressed to acquire at the same time. That doesn't mean that you shouldn't put the information of how you got that information out there. Again, transfer of knowledge here is important. Okay, so we document that data provenance part. So let me actually walk you through what we do at the journal, and that will lead into how you might want to think about what you do in an RDC in terms of doing that. So when we say we preemptively improve code archives, what do we actually do? Well, every paper that receives a conditional acceptance from an AEA editor needs to go through a series of checks. We check the data citations, and unfortunately, those are almost every paper initially failed on that metric, and I'll get to what data citations are briefly. We look at the quality of the README that's provided, and the README is kind of a generic term. It's it really encompasses many things that we'd like to have in there that go beyond just run this code, we're done. We briefly look at quality of code. We're not doing code analysis. We are not doing code consulting. But what we do want to do is, can a reasonable person who has had no prior exposure to your code in combination with a README find out where are things being done? Where is table 1 being generated? Right? That should be obvious. That can be done in many ways. We don't prescribe any particular one, but there are ways that are better than others. And then if we have the data, we also look at the reproducibility of the code. Are all the pieces there? And are you outlining what are the minimum requirements to run this code? And finally, and this is specific to the way that we've implemented these things, we look at the quality of the metadata in the repository. So at a minimum, it should, of course, list the authors, but it needs to list all the authors. It needs to have a meaningful abstract. Ideally, it has some information about what country is this data for, because it's the American Economic Association's journals, but we don't publish just data on the US. And so having some additional metadata in the archive is useful. I'm not going to focus too much on those aspects here because those are somewhat specific to the AEA, and I'm going to focus more on what is doing that. All of these checks are absolutely out there on the web. You can see template implementations of these. You can follow through on this, and there's a bunch of links at the end of this presentation that we'll make available after the talk as well. How do I do that? Obviously, I don't do that on my own. There's a huge bunch of students who are working with me on that. That's the advantage of working for the AEA, is that there's actually money associated with the data editor position. So here's a rough list of all the students that have worked with me on this. Almost all of them are undergraduates. So this is not something that needs to be complicated. It's not something that should be complicated, because the complicated part is coming up with the analysis and the code. Running it should not be hard. So all of those in blue are those who are currently working with me. Those in black are those who in the past 2 years have worked with me. So we have a constant flow of students joining our lab, of students leaving our lab, and hopefully going out into the world with more replication exercise. Harry is my current graduate assistant, and my assistant overall is Michael, who we just recently hired, who's offloaded a lot of stuff from me as well. Now, one of the reasons why this actually works in economics with undergraduates is that we really don't have a huge diversity in software. Almost all of the archives, 72%, 73% are in Stata, 22% are MATLAB, and then there's a smidgen of other stuff that is run after that. So we can cover many of these. It is rare that none of us on the team has some knowledge on how to run things. GIS is a bit of our weak spot, but that, as it turns out, is a weak spot for most economists who use GIS as well. So that helps. The template that they walk through, that is the, if you like, blank report and instructions on how to fill it out, is again totally public. If you want to have a look at it, if you want to do this on your own, it's right there. So that's absolutely possible. And I think we just crossed the line of 1,000 assessments, 1,000 reports requested. We haven't written all of those yet, so that takes another 2 or 3 weeks. Since July of 2019, most articles come back to us because they have things that need to be fixed. So 1,000 assessments means that that's approximately 400 articles that have gone through the process and have already been accepted. So the median times we see an article is 2. That's 1 too many times. I dearly love for that to mean we see one and it works and we hand it off and we're done. But we're starting to see a few of those, but in the first round, we saw every article at least a second time. Okay. So going back to the challenges in RDC, how do you check the code as we do here when the data is complex? Well, here's approximately the process we go through. So we get a request for evaluation coming from the editorial office. We start by checking the data citation and provenance stuff. And then we figure out, well, now that we know where the data is coming from, can we access the data? That might mean that the author provided us with the data, which, by the way, does not obviate the need to document where the data came from in the first place. And even if the author provided the data, we will go back and check if you can actually get the data the way that the author said they would, and if it's the same data. Right, so suppose we can access the data, then we'll conduct a reproducibility check. We will actually run the code and see if every table and every number in every table matches what's in the article when we run the code. If we can't access the data, though, the question then is, do we know how to access the data? Can we get at it in a timely fashion, or do we know somebody else who can? Right? And so if that somebody else is accessible in a timely fashion and can do this, then we ask that third party, as I refer to them generally, to conduct a code check. And if we can't, then we conduct a code check and essentially say, seems to be that this code could be executed, but we don't know that. But if we do know somebody, then we contact that third party, who will then conduct more or less the same reproducibility check for us, and will send us back a report on that. Right? And from all of those components, we ultimately create a summary indicator of reproducibility and put all those things together and send it back to the author. Hopefully it says that this is all fine and it works fine, and we found every table and the code spit out every figure that is needed, and you've cited where the data comes from, and we've checked and that's actually true, and so you're good to go. If not, the report will contain indications of how to palliate those problems that we identified. And again, with the limitation that we're not a code consulting job, so we won't rewrite your code to be cleaner, etc. We will offload that onto the authors. Okay. So what does reproducibility check, that key component in there, actually mean? That's the report I pointed you guys at earlier, and that contains various steps that we essentially go through. So I'm going to focus here on what the actual reproducibility check has. There's more components to that. But we go through data checks, code description, checking the requirements, checking what the code actually does, and then running through the code and making findings. Data checks should be pretty obvious when you're in an RDC. They're not necessarily when we get data from authors, namely, first of all, can the data actually be read? We kind of have a look at archive-ready formats, probably to not along the lines of what data librarians would wish it to have. They want archive-ready common formats. We're actually fine with stuff like Stata data sets or R data because they can be read by open source software. That's kind of our criterion. Even if it's Stata, which is commercial software data set, there's R code, there's Python code. You can read Stata datasets with SAS, so you're not locked into that dataset, and that's enough for us. We do like datasets that are provided us to have variable labels because those help other users down the road to understand what it is. That's not just a column called V1 that has some numbers in it, but that actually means something. And in data that we obtain, we do run a cursory check for personally identifying information because it shouldn't really be on there. That's a plausibility check. The authors are responsible for that, but we do occasionally find cases where they missed a few things. We then go through the code and have a look at, do we think all the pieces are there? We actually want data preparation code. That is a change from the previous policy. We actually want your data cleaning code, not just the analysis code. So we don't want just the code that produces a figure. We want the code that creates the data set that you then use to produce the figure. There's a lot of skeletons in that particular closet that we want to get out into the open. And the key thing is that we'll look through the code, and this doesn't require you to run any code. It doesn't require you to have any knowledge of the code. There needs to be some English language identification of where is table 1 as it appears in the paper written out, right? And you might have called that table LaTeX table OLS2, and it might turn out to be table 1, then we need a mapping to that. It should be obvious for somebody coming to the code, where are the numbers being generated? Because I might not want to generate all 15 tables that you generate. I want to focus on one. I want to know where that's being done. So software requirements are one of those sleeper things. You might think it obvious. Yeah, I pressed the button and I went home, and the next day I came back in the RDC and it was done, and that's fine. But we kind of want to know, because what you think is acceptable in terms of a length might not be for the next person over. There are people who think if it runs more than 30 minutes, that's long. There are people who think that running 3 weeks is not long. And so we compare things like that. We also want the packages. We want some verbose description, and then we actually go in and actually look at the tables and figures and actually compare them to what's out there. So when we reach out to third parties, we ask them to do something similar. We have, over the past year and some months, worked with various contributors to that. I do call out Cascade in France, who've been very generous with providing us with a third-party report, even when the data is not confidential, because that's kind of what they do. Sizer at Cornell has one of those services. A few universities have these kinds of services on campus, so we've been working occasionally with them. They tend to adopt our methods in general for other purposes as well, but they've been very useful for doing that. Cascade in particular is relevant for thinking about how one might want to set something like that up in an RDC, because they have access to the French RDC system, and they have run for us, and I'll get to that in a moment, analyses on the DADS, which is the linked employer-employee data in France, as well as French customs data, which is quite a store. But we also sometimes will reach out to the author themselves and say, look, we don't have access to this data. Do you have somebody who can conduct an arm's length reproducibility attempt at running through this data? And if you think of that, that can apply in the Canadian RDCs as well. You, as a PI on a project, might have an RA on it, and while the first paper was written by the RA who's since graduated, you now have a new RA who has also access to the same data and could conceivably conduct an arm's length replication attempt. So we have a few of those that are going on. So just sort of looking back at the past several months, we have successfully or currently in progress accessed via third parties Swedish data through a research institute in Sweden. We've gone through the Fed board. They provided us with access to some RAs to access proprietary data. We've had the Joint Committee of Taxation offered to review a paper that was written with IRS data. We've worked with the Upjohn Institute twice to access state-level administrative data that was not otherwise accessible. The Banco de Portugal helped us with a replication attempt that had used their lab. We have a few ongoing with the IAB, and we've reached out to graduate students associated with research projects that submitted to us at various universities. And just because they're graduate students, they actually did provide useful feedback. They did report on bugs that were in the code. And so these are useful exercises. Could this be done in the CRDCN? Yes, absolutely. And we can definitely talk about that after the talk. There's various paths to doing that, even in the absence of an archival policy at Statistics Canada. This is something that can be done as a summer project, as a course project, as long as the access conditions are met. This is certainly something that is feasible. So just very quickly about what we do at the Journal for Better Archives. And again, we try and leave data where they are. In some cases, we have to leave data where they are. So the advent of better archiving at Statistics Canada, or the presence that they actually already have some archiving system, their website is actually pretty good in an international perspective for that, is useful. The key guidance here are the FAIR principles. Some of you might have heard about them. FAIR is an acronym conveniently chosen to also seem very positive about findable, accessible, interoperable, and reusable. And one key aspect is that in order to use data, you need to find it. And so having some transparency about that is important. That means that when you can, you will make the data available, but more importantly, you will make the metadata about these things available so that you have the name of a database that you can find, you have whoever created it, but you also have citation of the data itself as distinct from the actual article. Those need to be machine readable, so search engines can find them. So while this is definitely not readable by humans, Google can read it, and you will be able to find the same data set through the Google dataset search. And so that's the ideal scenario. Can you currently find Statistics Canada data sets through Google dataset search? When I last put these slides together, I didn't find any, but that doesn't mean that that isn't happening. That can happen. So that contributes then to the better provenance tracking as well. So not just are our archives findable, but also if archives are findable, we can then link them back to the materials that we get here. And so that's where the data citations come in that I mentioned earlier. Data citation can be as simple as, even if it's on a website, it doesn't have to be an archive. You're still citing where the data comes from, the same way that you cite the authors of articles that provide data and intellectual contributions to your article. That is actually something that economists struggle quite a bit with. It is something that librarians struggle with because it is not something that has been traditionally done. Somewhat surprising because, at least in other disciplines, you can actually cite the box in the National Archives with a folder within that box that contains the particular piece of poetry that you used in English literature survey or whatever you did with that. So in order to help people along, we've put together, mostly me, I have put together this particular website with guidance on data citations, including many various scenarios that might happen, not just in an RDC, but also in more general sense. So let me give you some practical tips. Citations. The key answer we get back is if you can't download data, you can't cite it. And even if you download it, why should I cite something at the BLS or at Statistics Canada? The key aspect here is that the citation is the first step to identifying how access to the data can be done. So the additional information on the access that is tied to a data citation is just as important as the data citation. We look at, does the URL lead to the exact data? The World Development Indicator is, for instance, one example. Authors might point to the generic database. That's not sufficient for us. We need additional information. Is there a URL that might lead to the exact data? Can the query be embedded in the URL? That might be useful to put in the README. If not, then we need additional information. Does the URL lead to an application procedure, right? Do you need to sign or click through or do something? And is the access procedure somehow described, even if it's complicated? Somehow you need to convey how you access the data. Now, the subtlety is that the way you access the data might not be the way that others access it in the future. And that's why if you're accessing it, say, through the RDCN, I don't want your description as the primary one or the only one. You might have gotten access to it through a particular process, but if the data becomes available through a different mechanism, then that's great. And then that should also be a pointer in there. Now, that's not easy because you might have accessed it through your university library who has access to a proprietary database. That doesn't mean that you can describe to others who are not part of your university how to access that database. So it's not always easy, but we try. And I pointed this out on the title slide. What do we actually know about the license or data use information that's with that? Just because you see something on a website or just because you're allowed to download something from a website doesn't actually mean that you're allowed to provide us with a copy of that. So it goes both ways. In some cases, authors have told us, no, I can't give you the data. And we go back to them and say, yes, you can. And because the data is not on an archive, you should. And we're not going to go forward until you do. In other cases, we second guess whether the author who provided us with data is actually allowed to provide us with that data. So the key to both of these is that you need to read the data use agreement or license or whatever you click through in doing so, right? So for instance, the economic policy uncertainty website, something that of course has gotten a lot of use in the past couple of months as economic uncertainty has exploded. A lot of researchers, in particular macro, use this, and we had at least one of them who told us, yep, I can't give you the data because he correctly read that on the website there is a copyright posted. And copyright means it's not your data. You can use it for yourself, but you can't distribute it to others. We actually reached out to the data providers in this case, and so this is now an archival picture of that because they said, of course we want people to redistribute the data, and change the license so that now there is a Creative Commons license on that gives you the right, subject to citing the original source location, of redistributing the data. What that means is that, okay, yeah, now you downloaded the data, and you should be able to say, and the data is subject to a CC BY license, and by the way, every subsequent use of this data is also subject to that CC BY license, right? So rights to use the data apply in all of these instances when you've gone through all these various purposes of doing so. They might give you permissions, they might restrict certain uses. I just had a conversation yesterday with a researcher who said, in principle, I can give everybody the data, but I committed to the respondents that the data only be used for research. And I said, well, then you have to put it behind something that makes the user agree to that and prevents redistribution. So read the terms of use. In an RDC, that terms of use is your application procedure, which obviously prevents you from redistributing the data, but you are going to use other data as well. So think about that, right? So one way of doing this right that I particularly like is the German RDC system, at least at the IAB. There are many other RDCs out there. All of their restricted access data has unique digital object identifiers for particular versions. Those change over time, and each version maintains their own DOI. And if you click on those, you get a data description page, which among other things outlines how the current mechanism of accessing the data is structured. And so this is exactly the kind of thing that we want. It's not every site that has it as nicely packaged as the German site, but believe me, most researchers we've seen also aren't aware that the site they originally got the data from actually has that kind of information out there. And we actually go in and check some of these things. So for instance, the World Value Survey actually says in its terms of use, you should cite the data in a particular way. And most researchers have not. And we check, is that data citation in the article where it should be, or if not in the article, at least in the README. And then finally, we actually might go through that process, and we have sent back to authors a few instances where they use the World Value Survey, because when they downloaded the data, they agreed to exactly 3 conditions of use. Number 1, cite the data. Actually, 2, cite the data. 3, don't redistribute the data. And apparently they didn't read all the way through to 3. So that's one of the key things. So a couple of coding things that we've learned from looking at that many packages and going through. You start to implement the right structure the moment you start a project, right? Reproducibility is relatively painless if you think about it from the start. It can be very onerous if you have to reverse engineer your entire project to be reproducible at the end. There should be 1 or a very small number of master scripts. There should be no manual manipulation of parameters in order to get variance or robustness checks or things like that, right? There shouldn't be any manual copying of results. Don't have stuff show up in the log file and say, yep, that's the number I want. I'm going to copy it now into my Excel spreadsheet that somehow ends up in my document. Every programming language out there has multiple capabilities of spitting out figures and tables into formats that are then easily post-processable and turn up in the manuscript. We have lots of papers that have some numbers stuck in the text. Oh yeah, and by the way, 15% of respondents think this. That number is a computed number, and we want to know how you computed that. So even those in-text numbers should be somewhere well identified in the code. Taking a step back, you might be using a few packages within your Stata, R, Python, whatever scenario that are user installed. If you're working the RDC, you probably brought those in from the outside because you need permission to do something like that, or there might be a shared directory that has a few of those pre-installed. We blank out completely our environment for every project that gets replicated. So we have 0 packages installed. There is no such thing as a commonly installed set of packages. So you have to specify what are all those packages that you use. And these are pretty straightforward ways to do that in Stata so that you make it explicit where those are. And ideally, you actually redistribute those, if the license permits you to, those packages with your replication package, because at least in Stata, they are not versions. So installing the latest version of Reg HFDE doesn't give you the same result if you installed last year's version, because there have been bug fixes and other things. So reproducibility requires that you actually specify exactly which version it is. Ideally, you provide it. Replicability specifies where did you get it from. So the same kind of provenance questions. And by all means, clear instructions. My favorite counterexample is somebody who thought he was writing some novel because he had definitely nonlinear instructions where you read through an entire paragraph and then at the end says, but of course, before you get to do this, do these other 3 steps in reverse order. Checklist, please. So some of the other things, set directories, levels, and things like that once in your suite of programs, not all over the place, and definitely don't specify a hard-coded path somewhere on line 1502. There are ways to do that, either never to have to set it. There are packages in R and Python, or if you do it from the command line, you actually never have to set a global directory. Or if you do, then do it in one location and then use that as the basis for many other things. Again, there's examples on our websites on how to do that. Use placeholders for things. Those might be called globals or locals or libnames for something like that, but have a clear distinction between the various locations and use them. I already mentioned the tables. If you have to manually modify the code to say robustness check 1 is in column 1 of the table, robustness check 2 is in column 2 of the table, etc., and do that, you're looping through the code. Every programming language has some sort of subroutine. They might be called functions, do files, programs, macros, or subroutines. Write a parameter file, loop through them, do something. Don't have us modify the code manually. That is just very onerous. And it's onerous to you as a researcher as well, because suppose you want to run through all of your code again before submitting, because you kind of want to know that it actually is reproducible. If that actually means that you need to modify the code in 37 places before you can finally produce that one table, that's not just onerous to our replicators, it's onerous to you. And there are many easy ways to do that. Particularly pertinent for the RDCs, where it might simply be imposed on you, but again, take care, even when you're copying around data, clearly separate what is confidential data and public use data, not just in terms of where you store them on disk in your project space, but also how you process them. We've had quite a few papers where a significant chunk of the tables could have been produced solely with the public use data, but because the data generating code commingled the confidential data and the public use data into one file, that file wasn't doable. And so the code actually failed to produce the non-confidential data tables. The better examples we've had is where researchers have blanked the columns of the data that clearly come from confidential data. And so if those columns weren't being accessed, then the table code ran just fine. So there are various ways, again, of doing that. We often hear that it's onerous to review code, data code, SAS code, etc., because it has confidential parameters all over the place. That is a matter of concern, and that is an impediment to proper transparency of the code as well. So segregate the confidential parameters into files that you can clearly identify. This file, the whole file, is confidential, and the rest of the stuff is not, because it just references something in the abstract. So those things are very useful. And again, this is where using placeholders, globals, libnames, etc., comes in. And the key aspect for reproducibility that I find the most important one is a philosophical one. You are not the one who needs to worry about reproducibility if you don't want to. You probably should anyway, but you don't have to. But computational empathy, thinking about the next person to run your code, is, I think, the key aspect here. Now, whether or not the next person is you 5 years down the road because you finally got that R&R from a journal after the 10th submission is a different question. But at a minimum, think about the folks who are out there. The answer I've gotten back from a few authors about we can't replicate your problems on our computer, it runs just fine, is just completely beside the point. That's not the point of reproducibility, that it runs on your computer fine. It has to run on every other computer fine as well, or describe what the limitations are on those computers. Consider cross-platform programming practices. Don't think that everybody's on a Windows computer, or don't think that everybody's on a Mac. And there are ways to do that in all the languages. Path and file names are the obvious one. Don't ever use backward slashes in your Stata program, or in your R program, or where you can avoid in your SAS program. Those are definitely, those break when you run stuff on a Mac or on a Linux system, and you don't have to, right? And finally, ultimately, the replication package is not just something for clarity of your analysis. It is a tool to teach people on how to implement the knowledge that you have written up in your article. It is that one key piece that really will persist. And there is a connection between citability and teachability of this. Many of the Stata packages that you used implement techniques that are more widely used simply because they were made easy to access and thus were easily implemented by others. Ease of access is also what applies to a replication package. So let me skip through these examples. I already mentioned some of that. So how should you think about a replication package? Well, have somebody else read it. If my undergraduate replicators, who are good, but they don't by definition have a PhD or are even tenure track faculty, if they can understand the README, then at least that part is done, right? And I'm only half joking when I say ask your grandma. If she can understand the README about what you're doing, then somebody else can probably follow those instructions as well. And then we have a protocol of what that actually means, which is precisely what we do when we can't access the data, is we send somebody else out there with your README and with the instructions, do not contact the author, and then just try to walk through all of those instructions. So visualize that, think about it. Right? So that's the tension between access and reproducibility. But over the past 6 to 8 months, we've accessed French, Brazilian, US confidential administrator that we ourselves didn't have access to, purchased commercial data, proprietary data. We've signed a few NDAs in order to do this. Data with application procedures from China, from Europe, from various locations. We've logged on to remote computers. We've obtained the data for our computers. The key message to anybody working with restricted access data is, don't assume we can't access it. Assume we can. And then if it's not reproducible, we will find that. The role for journals here, and I'm talking here as the data editor of 8 journals, but not the only journals that he will apply to, is that these are general purpose methods. Most or almost everything that I've just outlined should apply and be appreciated by many other journals. In fact, we kind of created what my European colleague calls the Social Science Guild of Data Editors, but we sort of modernized the logo and things like that. So you will encounter data editors that do the kind of checking that we do here as well at various other econ journals. Something I hope is a growing set of econ journals, but is a generally accepted criterion. If you're submitting to the Canadian Journal of Economics, Marie might not run your code, but she definitely will second guess your code even in the RDC. And so let me put it this way, bad programmers, you're not safe anywhere. So let me stop there, and I apologize, that's the wrong DOI for this. But there is a DOI out there. And so if you go to the slides, then you'll have a ton of links as well on that.